Hi there, my name is James Vasenka and I'm Professor of Physics at the University of New England. I'm going to be showing you two activities today, the diffusion lab and the electrophoresis lab developed by the UMD Nexus group. I'm not going to be showing you any analysis, just a less expensive way to collect the data. Instead of using one of their inverted microscopes, I'm going to be using a much less expensive pocket inverted microscope called the Microscope. Truth in advertising, I have no connection with this company. I was simply looking for a cheaper way to do this particular activity, and I managed to find this microscope online through Kickstarter, and now they're a full-fledged company selling these microscopes. I think they're very high demand. It has a fixed inverted lens here, 100x, a fixed platform surface, fixed focus. Keep this in mind, you can adjust the focus for this particular activity. The way I plan to get around it is simply have a couple of these with different kinds of samples on them. Light source here, you put your cell phone on top in order to record the data, which I'll show you right now. So I'm trying to do this all in one take. We'll see how lucky I get. Here is our apparatus. You can see the microscope right there. We've got a light source right there. I'm going to go ahead and put in some 8-micron beads right now. 20 microliters, about 0.6 grams per liter. Make sure you shake these things up and sonicate them. 0.1 gram per liter, 1 micron beads. Give them a little mix. Appear to have good contact with the leads there. Pop off the microscope and bring it down over the top here. Look for that big bright light. There's one. Look at that. That's an 8-micron bead right there right now. I'm lucky to find that right in the first shot. There are other ones too. We've got to zoom in. And there they are. Okay. Let's do the one that's a little bit more kludgy first activity, which is the electrophoresis lab activity. The reason why it's a little bit more kludgy is you have issues with the leads, making sure that they're just right. I hope to work with a company to have them develop something that's a little bit more robust than what I currently have, which is electrical wires attached by tape. I'm actually going to get that bigger. Oh, there's another bead coming in there. Okay, well, we've got 8-micron beads on both sides here right now. So we're going to go ahead and get these suckers to migrate across the surface by turning on the electric field. These bigger clusters that you're seeing going through the middle field are almost certainly unsonogated samples of 1-micron beads clustered. I'm going to turn back. I'm going to flip the leads, see if I can go in the opposite direction now. You can see they're undergoing random Brownian motion. So there's one of those large beads there that looks like a red blood cell, and that's just refraction taking place at the edges of it. We can get them to go. Oops, excuse me for just a second while I get this back into focus. So it's a little bit more persnickety when it comes to focusing. So I'm going to see if I can get it now to move while the other smaller 1-micron beads are standing still. And you'll notice that this is opposite to the electric field that we were doing earlier, so it can't possibly have anything to do with electric field. I'm going to now make it go back in the other direction. Oh, a couple of them, good. And why is that happening? Well, I'm going to quickly zoom out and show you that what you can do with this microscope, of course, is, since it's so small, it's pretty trivial just to go ahead and tilt it back and forth. Anyways, that's the device there, and there's a QR code if you want to go ahead and order one. Yep, highly recommend them. Thank you very much. Kept it under 5 minutes.